that. You take 4 points. You draw X in between them. Anyone can go do this on a basketball or a beach ball. Take 6 pieces of string. Make any kind of 4-sided shape, as long as you don't turn the strings left or right. Pull them tight on the surface of the ball. Then you do the same thing with the X in the middle of them. Now take all those pieces of string, go put them on a desk or your kitchen table. Okay, the X is in the middle. You won't be able to make them match up. All right, Elijah, listen, it's not a losing argument. I don't know if you saw what happened. Second of all, if you think you know the distances, I'll debate you on it, because if you say they got the right distances, you're going to have a hard time drawing a square or a triangle with the distances they gave, and not have it be on a planar surface. Here's a newsflash: if you give them the distances they claim, Earth's not a planar surface. The reason why it can't be a planar surface is because of the Pythagorean theorem. If you draw a square on a surface, and you know the distances between all the points on the square, and you draw X through the square, you will absolutely know if that is a planar surface or not. If you give them the distances, okay, Earth is not a planar surface, because you can draw a square on the ground or over the surface of the map, and you'll find out that if you use Pythagorean theorem, it's not gonna add up. It's gonna show you that it's not happening on a planar surface. If you put 4 points on the ground and an X in between those 4 points, you will absolutely be able to tell if it's a planar surface or not. Yeah, if you put 4 points on the ground, this has nothing to do with geometry, all right? It doesn't even have to be a square. 4 points on the ground, okay? We don't know what the surface is yet. No presuppositions or nothing. You just have 4 points on the ground. And then you know the distances between all these points, every single one. It will absolutely tell you if it's a planar surface or not. So if you think arguing distance is a losing battle or a waste of time or whatever.
It's simple. It's a squared plus b squared equals c squared. Okay, if you have these 3 points, you don't even need 4.
Okay, that's a planar function.
Be able to figure out. Hold up. This only applies to plane geometry, Euclidean geometry, right?
That's what I said.
If you calculate c, like the hypotenuse, to be in line with plane geometry, then it's a plane. If it's more than that, if your distances are accurate to begin with, if it's more than that, then it's not a plane. It's, it would have to be spherical.
Yeah. If you give them these distances, these distances can't happen on a planar surface. They can take 5 points, 4 points at sea level, draw X in between them, because they know those distances too. You go to scale that down and put it on a planar surface, it ain't gonna happen.
If we concede their distances, we're done. If we concede their distances, we're done. If we concede their distances, we're done.
Right? How you can tell if it's a planar or a non-planar surface, what these distances are on. You can get 6 pieces of string, put it on a ball or any curved surface. It doesn't even have to be a ball. It can be convex, concave, whatever. Just make sure it's not planar. Take the distances between all the strings, pull them tight over the surface of the ball, make an X with 4 sides and an X in the middle. Take your lines, put it on a table, all right, or a desk or whatever flat surface you got. The X will not marry up. So we now know how to tell if it's a plane. That the distances will definitely tell us if it's a planar surface or not, right? This doesn't give you a shape. This will just tell you if it's planar or not. And if you take the lengths of string or the distances, or the distances they give, whatever you want to do on a ball yourself in a planar surface, or a bowl, you can get a cereal bowl and do this. Anything that's not planar and something that is planar, and you have these distances, the X won't marry up on the planar or spherical surface. I'm trying to prove to people that distances, I'm trying to prove to people that if you have 4 distances in a straight line, straight, not turning left or right, staying equal elevation, If you have 4 distances, and you know the distances between all those points, meaning you know the X distance in between the 4 corners, you will be able to tell if the surface is planar or not. Hold on, guys. The point is, can I respond to that?
Go ahead.
The point of that whole thing was, now everyone knows that if you give them the distances, it's not a planar surface, right? Do we all know that now?
No.
Yeah, that's cool, but the distances they give us, that they say that things are, those distances, they say that they can't, that those distances can't work on a planar surface.
Yeah, that's a straw man.
No, it's not a straw man.
Can't be.
It's not a straw man. If geometrically cannot work on a planar surface, it's not a straw man.
It's a Superman.
Okay, so how'd they get so time out. So the distance that they're telling you can't work on a flat plane. How the fuck did they get that? Stop. How did they get that distance, Jeremy? Do you know?
There's a couple maps you could work on, but not the AE map.
No. You make a map after you've taken angular measurements. You don't start with a map. So rewind. How the fuck are they giving you a distance, Jeremy? Please explain to me what it is.
Do they not? Listen, that's what I was asking B-Ball for. How did you get the distance?
Okay, he's lying. That's the point. He's lying.
Hang on, though. So when you asked B-Ball how you got these distances, what did he say, Jeremy?
He just kept saying we know.
Is the distance right or wrong?
Funny.
That is the question.
She's like, you don't think they know? Like hundreds of years?
I mean, if I give you a distance,
Jeremy?
am I lying about the distance, or do I give you the correct distance?
How are you going to be an adult in 2022 and say they're lying about distances, bro? We know distances all over, no matter where you want to go. You can book a flight right now, and they'll tell you how far away it is.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.